Hello, in this lecture we'll find out the value of angle theta. In the drawing, we have triangle ABC. Triangle ABC is an isosceles triangle because side CA equals to side CB. In addition, you know that this angle ACB equals to 20 degrees in its size. This angle NAB equals to 50 degrees. This angle ABM equals to 60 degrees, and our mission is to find out the size of angle NMB that is actually equals to angle theta. Okay, so first of all I will copy triangle ABC in a new page, and we will analyze this triangle ABC. So actually, this is triangle ABC that I copied from the original drawing. This triangle ABC, side CA equals to side CB, and this angle ACB equals to 20 degrees in its size. And we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of those two equal sides must be also equal to each other. So if one angle is theta, the other angle must be also equal to theta. And we also know that the sum of the angles in any triangle is equal to 180 degrees. Therefore, the sum of the angles in triangle ABC is equal to theta plus theta is 2 theta. Two theta plus 20 degrees must be equal to 180 degrees. We subtract 20 degrees from this equation, and finally we get that 2 theta equals to 180 degrees minus 20 degrees, it is 160 degrees. We divide this equation by 2, and finally we get that angle theta equals to 160 degrees over 2, it is 80 degrees. So angle theta equals to 80 degrees in its size. So here this is angle theta that is equal to 80 degrees in its size, but part of angle theta that is actually angle NAB, it is already equals to 50 degrees, therefore the missing angle must be equal to 30 degrees in order to complete the size of this angle, angle theta to 80 degrees, the missing angle here it must be equal to 30 degrees. Likewise, this is angle theta that is equal to 80 degrees, but part of angle theta, that is to say angle MBA equals to 60 degrees. Therefore, the missing angle must be equal to 20 degrees. In order to complete the size of this angle, angle theta to 80 degrees, the missing angle must be equal to 20 degrees. In the next step, I'll copy triangle NAB, this triangle NAB in a new page, and we'll analyze this triangle NAB. Angle NAB, this angle equals to 50 degrees in its size. Angle NBA, this angle equals to theta, it is equals to 80 degrees. That is the angle that we found a couple of minutes ago. So this is triangle A and B, that I copied from the original drawing. We define the missing angle, this angle is theta. The sum of the angles in triangle A and B must be equal to 180 degrees, that is to say 50 degrees plus 80 degrees plus the missing angle, that is angle theta. In total, the sum of three angles, those three angles must be equal to 180 degrees. 50 plus 80, it is 130, so we subtract 130 degrees from this equation, and we get that angle theta equals to 180 minus 130, it is 50 degrees. So this angle theta equals to 50 degrees in its size, that is to say, angle A and B equals to 50 degrees in its size, so this is angle A and B that is equal to 50 degrees in its size. We'll continue to focus on triangle A and B, this triangle. In triangle A and B, we have those two angles that are both equal to 50 degrees, therefore they are equal to each other. And we have the rule that in front of equal angles in the triangle, they are equal sides. So in front of those two equal angles, we have those two sides that must be also equal to each other because they are located in front of equal angles. That is to say, side AB equals to side NB. AB equals to NB. So I'll write it down here. Let AB equals to NB, and also here side AB equals to side NB. Okay, so in the next step, I'll copy triangle AMB in a new page, and we will analyze this triangle AMB. Okay, so here, triangle AMB, we have this angle is equal to 80 degrees. Angle MAB. Angle MBA equals to 60 degrees in its size. So actually, this is triangle MBA, as I call it from the original drawing. we define the missing angle as theta. In triangle MBA, the sum of the angles must be equal to 180 degrees, that is to say 80 degrees plus 60 degrees plus the missing angle, that is angle theta, this angle. In total, the sum of those three angles must be equal to 180 degrees. 80 plus 60 it is 140 plus theta equals to 180. We subtract 140 degrees from this equation, and finally we get that angle theta equals to 180 minus 140, it is 40 degrees. So the missing angle theta equals to 40 degrees in its size. That is to say, angle AMB equals to 40 degrees in its size. This is angle AMB that is equal to 40 degrees in its size. Okay, so in the next step, we do a construction. That is to say, from point B, we'll draw a line segment BD in such a way that we'll draw line segment BD on CA in such a way that BD will be equal to BA. Again, BD will be equal to BA according to our construction. Again, this is line segment BD that is equal to BA according to our construction. So we write it down. BD equals to BA here, side BD equals to side BA. Okay. In the next step, I'll copy triangle BDA in a new page and we'll analyze it. So this is triangle BDA, that the copy from the original drawing. BA equals to BD according to our construction. I write it down. BD equals to BA according to our construction. This angle DAB, this is angle DAB, this is equal to 80 degrees. And because of the fact that those two sides are equal to each other, we have the rule that in front of equal sides in the triangle are equal angles. So those two angles that are located in front, those equal sides must be equal to each other. But this angle equals to 80 degrees, therefore the other angle must be also equal to 80 degrees. That is to say, angle ADB equals to 80 degrees in its size, so we write it down here. This is angle ADB that is equal to 80 degrees in its size. We continue to focus on triangle BDA. In triangle BDA, the sum of the angles must be equal to 180 degrees. So which angles we have here? We define the missing angle as theta. So 80 degrees plus 80 degrees plus theta. In total, the sum of those two angles must be equal to 180 degrees. 80 plus 80 is 160, so 160 degrees plus theta must be equal to 180 degrees. We subtract 160 degrees from this equation, and finally we get that angle theta, the missing angle theta equals to 180 degrees minus 160 degrees, it is 20 degrees. this angle equals to 20 degrees in its size. That is to say, angle ABD equals to 20 degrees in its size. So I write it down here. This is angle ABD that is equal to 20 degrees in its size. So actually, we have here the small angle here is angle ABD that is equal to 20 degrees in size. The big angle is angle MBA, this angle that is equal to 60 degrees in its size. It is very easy to see from the drawing that the big angle MBA minus the small angle DBA must be equal to this missing angle, that is actually angle MBD. So I write it down. The big angle, that is actually angle MBA, minus the small angle, that is actually angle DBA, must be equal to the missing angle, angle MBD. Repeat again, the big angle MBA minus the small angle DBA must be equal to the missing angle, angle MBD. The big angle MBA equals to 60 degrees in its size. The small angle DBA equals to 20 degrees in its size. So 60 minus 20 is 40 degrees. So the missing angle MBD equals to 40 degrees in its size. So I write it down. Angle MBD equals to 40 degrees in its size. Okay, in the next step, we focus on triangle DMB, this triangle, so I copy triangle DMB in a new page and we will analyze it. But before that, we have here two equations. From one side, AB equals to NB. From the other side, AB equals to BD. AB equals to BD. So, and from this equation, AB, BD equals to AB equals to NB, we will derive that BD equals to NB. BD equals to NB. Here, side BD equals to side BD. Those two sides are equal to each other. Okay. So in the next step, I'll copy triangle DMB in a new page and we will analyze this triangle, triangle DMB. Angle DMB equals to 40 degrees in its size. And just like I found out that angle DBM, this angle also equals to 40 degrees in its size. So actually, this is a triangle DMB that I copied from the original drawing. Those two angles are both equal to 40 degrees, therefore they are equal to each other, and we have the rule that in front of equal angles in the triangle, there are equal sides. So those two sides that are located in front of those two equal angles must be equal to each other. That is to say, DM equals to dB. So I write it down here. dm equals to dB. And you also side dm equal, this is side dm, this is equal to side dB. Okay. In the next step, we join points D and N together by a straight line. And we will focus on triangle D and B. We focus on the green triangle, this green triangle, triangle D and B. So I copy triangle D and B in your page, we will analyze it. Angle NBD, this angle NBD equals to 40 degrees plus 20 degrees, that is 60 degrees. And we already found out that dB equals to NB. Here, dB or BD equals to NB. Here, dB equals to NB. So actually, this is triangle D and B, the decorator of the original drawing. We already found out that angle NBD equals to 60 degrees and dB equals to NB. Again, we have the same rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of those two equal sides must be equal to each other. So if this angle equals to theta, then the other angle must be also equal to theta. And the sum of the angles in the triangle is equal to 180 degrees. And especially it is true in triangle DNB. So theta plus theta is 2 theta. Plus this angle is equal to 60 degrees. In total, the sum of those two angles must be equal to 180 degrees. We subtract 60 degrees from this equation, and finally we get that 2 theta equals to 180 degrees minus 20 degrees. It is 160 degrees. $180 degrees on 60 degrees, it is of course 120 degrees. So 2 theta equals to 120 degrees. We divide this equation by 2. And finally we get that angle theta equals to 120 degrees over 2, it is 60 degrees. So angle theta equals to 60 degrees in its side, so this angle theta equals to 60 degrees. This angle theta also equals to 60 degrees in its size. So we actually found out that in triangle NBD we have three angles that all of them are equal to 60 degrees in their sizes. Therefore triangle NBD is an equilateral triangle. So I write it down. triangle NBD is an equilateral triangle. Okay, and we also know that all the sides of an equilateral triangle are equal to each other. So in triangle DNB, DN equals to NB equals to DB. Those two sides are equal to each other. Repeat again, in triangle DNB, DN equals to NB equals to DB. So I'll write it down here. The DN equals to NB equals to DB. Okay. Here also DB equals to DN equals to NB. So here we have two equations. According to this equation, dB equals to dm. So I write it down. dB equals to dm. But according to this equation, dB equals to dn. So you can write here that dB also equals to dn. And for this equation, dm equals to dB equals to dn, we will derive that dm equals to dn. dm equals to dn. Here, side dm equals to side dn. Those two sides are equal to each other. Okay, in the next step, we'll focus on this side of the straight line CA at point D. So I copy the straight line CA here. This is the straight line CA. We focus at point D on this straight line. Which angles we have on this side of the straight line CA at point D? We have this angle that is equal to 80 degrees. This angle is one out the three angles of the equilateral triangle, therefore it must be equal to 60 degrees in its size. Okay. So those are the angles that are located on this side, the right side of the straight line CA at point D. 80 degrees plus 60 degrees plus the missing angle. In total, the sum of those three angles must be equal to 180 degrees. According to the rule that the sum of the angles from one side of the straight line is equal to 180 degrees. So 80 plus 60 is 140. So the missing angle must be equal to 40 degrees. In order to complete the sum of the angles on this side of the straight line CA at point D to 180 degrees, the missing angle must be equal to 40 degrees. So actually here, the missing angle here is angle MDN that is equal to 40 degrees in its size. So in the next step, I'll copy triangle MDN in a new page and we will analyze it. So actually, this is triangle MDN. We take copy from the original drawing. We have already found out that dm equals to dn. Here, dm equals to dn. So again, we have the same rule that in front of equal sides in the triangle, there are equal angles. So those two angles that are located in front of those two equal sides must be equal to each other. So if this angle is theta, then the other angle must be equal also to theta. In triangle DMN, the sum of the angles must be equal to 180 degrees. So theta plus theta is 2 theta plus 40 degrees. In total, the sum of those three angles must be equal to 180 degrees. We subtract 40 degrees from this equation, and finally we get that 2 theta equals to 180 minus 40, it is 140. So 2 theta equals to 140 degrees. We divide this equation by 2. And finally we get that angle theta equals to 140 degrees over 2, it is 70 degrees. So this angle DMN equals to 70 degrees in its size. So this is actually angle DMN that is equal to 70 degrees in its size. Again, this is angle DMN. This angle that is equal to 70 degrees in its size. So the big angle that is DMN minus the small angle that is actually angle DMB. The difference between those two angles must be equal to the missing angle, that is angle theta, that is the angle that we are looking for. So the big angle DMN, this is the big angle DMN, minus the small angle DMB must be equal to the missing angle theta. So I write it down. So the big angle, that is actually angle DMN, that is equal to 70 degrees in its size, minus the small angle, that is actually angle DMB, that is equal to 40 degrees in its size, must be equal to the missing angle, that is angle theta. Angle theta is actually also equals to angle NMB. So I'll repeat again. The big angle DMN that is equal to 70 degrees in its size, minus the small angle DMB that is equal to 40 degrees in its size, must be equal to angle theta, that is angle NMB, that is the angle that we are looking for. So 70 minus 40, it is 30 degrees. So actually found out finally that the missing angle theta, that is the angle that we are looking for, it is equal to 30 degrees in its size. This is angle theta that is equal to 30 degrees in its size. So in the next step, I will summarize the lecture. this lecture we found the size of this angle, angle theta, that is actually also angle NMB. It's given us in the question that triangle ABC is an associated triangle. Why? Because side CA equals to side CB. And we also know that this angle ACB equals to 80 degrees, 20 degrees in its size. Angle NAB equals to 50 degrees in its size. And finally, angle MBA equals to 60 degrees in size. Our mission is to find out the size of this angle, angle theta, that is actually also angle NMB. So first of all, I'll copy triangle ABC in a new page and analyze it. This is triangle ABC that I got from the original drawing. Side CA equals to side CB. In addition, we know that this angle ACB equals to 20 degrees in size. Because of the fact that those two sides are equal to each other, we have the rule that in front of equal sides in the triangle, there are equal angles. So those two angles that are located in front of the equal sides must be equal to each other. So if this angle is theta, then the other angle must be also equal to theta. And you also know that the sum of the angles in any triangle is equal to 180 degrees, and especially it is true in triangle ABC. So that is to say theta plus theta is 2 theta. 2 theta plus 20 degrees must be equal to 180 degrees. We subtracted 20 degrees from this equation and finally found out that 2 theta equals to 180 degrees minus 20 degrees, it is 160 degrees. We divided this equation by 2 and finally found out that angle theta equals to 160 degrees over 2, it is 80 degrees. So this is angle theta that is equal to 80 degrees in size, and this angle theta also equals to 80 degrees in its size. So here, this is angle theta is equal to 80 degrees, but this angle NAB is part of angle theta, and it is already equals to 50 degrees. Therefore, the missing angle must be equal to 30 degrees. In order to complete the size of angle theta to 80 degrees, the missing angle must be equal to 30 degrees. Likewise, this is also angle theta that is equal to 80 degrees in its size. But because of the fact that part of angle theta, that is angle MPA, is already equal to 60 degrees, the missing angle must be equal to 20 degrees in order to complete the size of this angle theta to 80 degrees. The missing angle must be equal to 20 degrees in its size. Then we focus on triangle, this triangle NAB. So I call it triangle NAB in your page and analyze it. This is triangle A and B that I copied from the original drawing. So angle NAB equals to 80 degrees in size, and this is actual angle theta that is equal to 80 degrees, and this is the missing angle. Okay, we define the missing angle as theta. The sum of the angles in triangle NAB must be equal to 180 degrees, that is to say 50 degrees plus 80 degrees plus theta. In total, the sum of those three angles must be equal to 180 degrees. 50 plus 80 is 130. So we subtracted 130 degrees from this equation, and finally we found out that angle theta equals to 180 degrees minus 130 degrees, it is 50 degrees. This is the missing angle theta, this is equal to 50 degrees in size, that is to say angle A and B equals to 50 degrees in size. Here, this is angle A and B, this is equal to 50 degrees in size. We continue to focus on triangle A and B. On this triangle A and B, those two angles are equal to each other. They are both equal to 50 degrees, therefore they are equal to each other. And we have the rule that in front of equal angles in the triangle, they are equal sides. That is to say, in front of those two equal angles, we have those two sides that must be also equal to each other. That is to say, side AB equals to side NB. AB equals to NB. Here we hold down here also that side AB equals to side NB. And here also side AB equals to side NB. Okay. In the next step, we copy triangle MA and B, this triangle A and B in the new page and analyze it. actually, this is triangle A and B that I call it from the original drawing. This triangle, angle MBA equals to 60 degrees inside, and this angle MAB equals to 80 degrees. Also the two angles. And this is the missing angle that we define as theta. The sum of the angles in triangle MAB must be equal to 80 degrees, that is to say 280 degrees. That is to say 80 degrees plus 60 degrees plus theta, in total the sum of those three angles must be equal to 180 degrees. 80 plus 60 is 140, so we subtract, so 140 plus theta equals to 180 degrees. We subtracted 140 degrees from this equation and finally found out that angle theta equals to 180 minus 140, it is 40 degrees. So angle theta, that is actually angle A and B, equals to 40 degrees in its size. So you can write here that angle A and B, this is angle A and B, that is equal to 40 degrees in its size. Okay, so in the next step, we did the construction. From point B, we draw line segment BD on CA in such a way that BD equals to BA. Again, BD equals to BA according to our construction. So here, BD equals to BA. Then I copy triangle ADB in the new page and reanalyze it. This is triangle ADB that I copied from the original drawing. Repeat again. The BD equals to BA according to our construction. Angle DAB equals to 80 degrees. This is angle DAB is equal to 80 degrees. And those two sides are equal to each other. Again, we have the same rule that in front of equal sides in the triangle there are equal angles. So in front of those two equal sides, we have those two angles that must be also equal to each other. But this angle equals to 80 degrees, therefore the other angle must be also equal to 80 degrees. That is to say, angle ADB equals to 80 degrees in its size. Here, angle ADB, this angle equals to 80 degrees in its size. We continue to focus on triangle ADB. In triangle ADB, the sum of the angles must be equal to 180 degrees. So we define the missing angle as theta. So 80 degrees plus 80 degrees plus theta, in total the sum of those angles must be equal to 180 degrees. 80 plus 80 is 160, so 160 degrees plus theta equals to 180 degrees. We subtracted 160 degrees from this equation. And finally found out that the missing angle theta, this angle, equals to 180 minus 160 is 20 degrees. So angle theta equals to 20 degrees in its size. Angle theta is angle ABD, that is equal to 20 degrees in its size. Here, this is angle ABD, this angle equals to 20 degrees in its size. Then we have here the small angle ABD, it is equal to 20 degrees in size. The big angle ABM equals to 60 degrees in size. So the big angle minus the small angle must be equal to the missing angle, that is actually angle MBD. Okay? The big angle ABM minus the small angle, that is angle ABD, must be equal to the missing angle, that is actually angle MBD. And repeat again. The big angle, that is angle MBA, that is equal to 60 degrees in size, minus the small angle, that is actually angle DBA, that is equal to 20 degrees in size, must be equal to the missing angle, that is angle MBD. 60 minus 20 is 40. So we found out that the missing angle MBD, this angle equals to 40 degrees in its size. Okay. Then focus on triangle D and B. Actually, here we join points D and N together by a straight line. And then we focused on the green triangle, triangle DNB. In this green triangle, triangle DNB, angle NBD equals to 20 degrees plus 40 degrees, that is 60 degrees. So actually, this is triangle DNB that I copied from the original drawing, angle NBD equals to 60 degrees, and we have already found out that DB equals to NB. Again, here, DB equals to NB. Again, here, why DB equals to NB? But because of the fact that from one side AB equals to NB. AB equals to NB from one side, but from the other side, AB also equals to BD. Here, AB also equals to BD. And from this equation, BD equals to AB equals to NB, we will derive that BD equals to NB. Okay, so here, BD equals to NB. BD equals to NB, and again we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front, the equal sides must be equal to each other. So if this angle is theta, then the other angle must be also equal to theta. The sum of the angles in triangle NBD must be equal to 180 degrees. That is to say theta plus 60 degrees. In total, the sum of those two angles must be equal to 180 degrees. We subtract the 60 degrees from this equation, and finally found out that 180 degrees minus 60 degrees, it is 120 degrees, so 2 theta equals to 120 degrees. We divided this equation by 2, and finally found out that angle theta equals to 120 degrees over 2, it is 60 degrees. So this is angle theta that is equal to 60 degrees in size, and this is angle theta that is also equals to 20 degrees in size. So we actually found out that this triangle DNB, it is an equilateral triangle. Why? Because all of its angles are equal to 60 degrees. So triangle NBD is an equilateral triangle, and we know that all the sides in any equilateral triangle are equal to each other. That is to say, ND equals to DB equals to NB. Repeat again. In the equilateral triangle NBD, all the sides are equal to each other. That is to say, DN equals to NB equals to DB. Here I wrote also that dn equals to NB equals to dB. Okay, so here we have those two equations. From one side, dm equals to dB, or dB equals to dm. Okay, dB equals to dm. dB equals to dm. But from the other side, dB also equals to dn. Here, dB equals to dn. So dB equals to dn. And from this equation, dm equals to dB equals to dn, we will derive that dm equals to dn. Again, dm equals to dn. dm equals to dn. dm, this is side dm, that is equal to side dn. Okay, then we focus on the straight lines on this side of the straight line CA at point D. This is the straight line CA, we focus at point D. On this side of the straight line CA at point D. So which angles we have here? We have this angle that is equal to 80 degrees in its size. This angle is one out the three angles of the equilateral triangle, therefore it must be equal to 60 degrees. So we have 80 degrees plus 60 degrees is 140 degrees, therefore the missing angle here must be equal to 40 degrees, because 140 plus 40 is 180 degrees. That is the sum of the angles on this side of the straight line CA at point D. Okay, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Therefore the missing angle here must be equal to 40 degrees in its size. That is to say, angle MDN equals to 40 degrees in its size. In the next step, I copy triangle MDN in a new page and we analyze it. This is triangle MDN is the code from the original drawing. We just right now found out that angle MDN equals to 40 degrees, and we already found out that DM equals to DN. Here, DM equals to DN. So dm equals to dn. So those two sides are equal to each other. Again, we have the same rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of those two equal sides must be equal to each other. So if this angle is theta, then the other angle must be also equal to theta. And the sum of the angles of triangle MDN is equal to 180 degrees. That is to say theta plus theta is 2 theta plus 40 degrees. In total, they must be equal to 180 degrees. Then we subtract the 40 degrees from this equation. And finally found out that 2 theta equals to 180 minus 180 minus 40, it is 140. So 2 theta equals to 140 degrees. We divided this equation by 2. And finally found out that angle theta equals to 140 degrees over 2, it is 70 degrees. So angle theta equals to 70 degrees. That is to say, angle DMN equals to 70 degrees in its size. So this is actually angle DMN that is equal to 70 degrees in its size. But the smaller angle DMB equals to 40 degrees in its size. It is very easy to see from the drawing that the big angle, this is actually angle MDN, this is angle MDN, minus the small angle, this is actually angle DMB. So the big angle minus the small angle must be equal to the missing angle, that is angle theta, that is the angle that we are looking for. Repeat again, the big angle DMN that is equal to 70 degrees in size, minus the small angle that is angle DMB that is equal to 40 degrees in size. So the difference between those two angles must be equal to the missing angle, angle theta, that is actually also angle NMB, that is the angle that we are looking for. 70 minus 40 is 30 degrees. So we found out finally that the missing angle, this is the missing angle, angle theta, that is actually also defined as angle NMB. It is equal to 30 degrees in its size. Okay, thank you very much.